Hey there, it's time for another update video. Before I continue, if you like my videos and my software, please hit the subscribe button. It helps increase the visibility of my channel and promote my new software better. So I've had a lot of things going on since last month, but the most exciting update is that I've begun alpha testing. I've given the software out to 3 users. Um, They've been testing with mixed levels of success. Some people have it's gone perfectly. Other people, they've run into some compatibility issues with their machines. But I've been working to resolve those issues, and honestly, I think it's going exactly as it should because I'm getting some feedback and some fixes in place before a larger pool of users jumps in. So, um, hoping that I'll be able to start throwing in more users into the pool soon. So stay tuned because there should be more people getting access to the software very soon if all goes well. Okay, I may have lied. There is another cool update which may be just as, if not more, exciting. And for this, I'm going to tell you a brief story. Um, so over the Easter break, um, with my father, we built a test model using the latest version, and I have that model right here. This is made with a CNC mill, 1/4 inch thick PVC. Um, this model was an interesting result. So what I noticed with this result was that the gears function quite well, but they were just a little bit snug, just a little bit too much grip, a little too tight, and in some cases that produces a small amount of resistance. So this got me thinking about different ways to handle it. This may have to do with the tolerances of the CNC machine. There's always a little bit of inaccuracies in the manufacturing, and often when you build the gears, you have to make certain allowances and adjust certain tolerances to account for that. And one of the common ways you do that with gear design is with backlash. So I started thinking about how I could incorporate a backlash capability into my software. So here's what I came up with. If I were to take all the right tooth flanks and rotate them by some constant angle about the center of rotation, and then take the left tooth flanks and rotate them the other direction by some slight angle, I am not actually distorting the perfect involute form, but I am thinning the teeth by adjusting their positions rotationally about the center. So what I can do now is, if I select my gear and I choose a backlash, let me choose a more extreme backlash so that it's more obvious. In fact, let me use 0.5 as my backlash. Heck, let's go a little further. Let's make it 1 full degree. Now I will use 1 degree of backlash for this gear. Alright, quite extreme now, but that's just for visual enhancement. So now these are both right hand side, left hand side. If you consider just the flanks, exact same tooth form as before, exact same relative placement between left hand flanks, exact same relative placement between right hand flanks, but they've been shifted slightly relative to each other. So let me rotate these together, review the contacts. Now watch what happens if I shift direction. It'll rock back in the other direction, and the contact will shift to the opposite side. Now, the reason that this is so cool is that, first of all, there's the virtual pitch curve, which defines how the gear should rotate. Now, when you're rolling in one direction, the right hand tooth flanks align with the pitch curves, or the virtual pitch curve, I should say. When you're rolling in the other direction, then the left-hand flanks align with the pitch curve. But in theory, only one of the flanks is in contact at a given moment. And so when they are actually touching, they are perfectly aligned with the pitch curve, and you should get the exact rolling properties, the exact relative motion that you're looking for. I think this is an extremely cool and beautiful solution to this problem, and it allows wiggle room without distorting the actual involute shape. So I would still need to go and trim my gear teeth as before, and in this case it actually needs to do 2 passes because it's going to roll forward and roll back with the 2 offset locations, and then I can preview the actual rolling. Another way that you can actually see the wiggle room is if you stop the rotation and just change the direction, you can see it wiggle back and forth. Now in practice you would use a lot less backlash. I think the default I have is 0.0125, or no, 0.025 I think is my default setting. Set that for this one, set that for this one, update my gears. So now if I zoom in really close and I jiggle, you should see just a very slight rocking. And you can adjust that angle to be whatever you want it to be for each gear. You can also adjust it for arc gears, rack gears, and so on, and everything should work out just fine. So I discussed that new feature with my father, and we were talking about, well, how do we figure out what backlash dimension to use? You know, we could build an entire model and it could just be the wrong setting, it could still be too snug, and then we'd have to start all over again. Also, we wanted to try making it with metal instead of with PVC, just to see if there would be any behavioral differences there. So what my father actually proposed was making sort of a pie slice gear where we would choose 6 different backlashes in each of a 1/6 sector region, so that in one gear, after manually stitching together 6 different slices, you could test a whole bunch of different backlash settings all in one device or mechanism. I call it the Franken gear because it was stitched together from many other gears. So he made that and did a very beautiful job with it, and also visually engraved the different backlash dimensions, and he sent me a cool demonstration video of the mechanism, which I will share with you now. The clinking lets you hear more obviously the increased and progressive backlash distance and the increased wiggle room with each test. So pretty cool. It seems to be working quite well. What was interesting was that the metal actually, even with a 0 backlash, had the smallest amount of wiggle room, unlike the PVC, which had a very snug fit. So that could again have to do with the tolerances of the CNC machine. It also could have to do with maybe there's some expansion of the material, which maybe the metal is not expanding. So very interesting case study. But I'm confident that with the right backlash setting, um, the gears should work just fine for your setup. Just need to adjust it based on the tolerances. So anyway, cool new stuff. I'll be in touch soon about adding new alpha users, and hopefully more people will be using the software soon. So hope you've enjoyed this update. Take care.